Hello. In this video we are going to discuss about confidentiality and integrity of WEP that is included in the WEP details topic itself. So in the last video we have discussed about WEP authentication, and this video we are going to discuss about confidentiality and integrity of WEP. So how is the encryption done in WEP? Actually, we have discussed this topic before in the last video. I'll discuss it once more. It includes a cipher encryption method is used here, and the ciphertext is calculated in such a way that the plain text is XORed with a key stream. The key stream includes a combination of two values, that is a shared secret key S and an initialization vector IV. So here C represents ciphertext, P represents plain text, and KS is the key stream, which is a 64-bit shared key, which includes a shared secret key of 40-bit and an initialization vector of 24-bit. Combinedly, it forms a 64-bit key stream value. And we use a CRC, that is message integrity check, and the decryption to find out the plain text from the ciphertext at the receiver is done using ciphertext is XORed with the key stream value, which is a combination of secret key S and initialization vector IV. And in the figure below, it is done how the frame is formed. The WP frame includes initial part is a MAC header. Then it includes the initialization vector, which is a 24-bit value. Then the encrypted plain text, which is P XOR KS of S, IV. Then it includes a message integrity check, that is CRC value. Then now what is the problem here? How is the attacker going to attack this? Here we use a key stream reuse method, because the key stream that is formed from the secret shared key S and IV is used again and again, and this is how the problem exists here, and it results in an attack. Okay, here we use the IV as a 24-bit value, and this there are only 2 raised to 24 different key stream options which can be easily reconstructed with a non-shared secret value S. So only the problem here is to use a IV, which is a 24-bit value. There are only 2 raised to 24 methods to reconstruct it. If you know the S value, it is very easy to find the key stream value. Now attacker find, if the attacker finds 2 different frames of same IV is included 2 different frames. One is plain text P and ciphertext C, another one is plain text P dash and ciphertext C dash. So it has 2 ciphertext C and C dash, 2 plain text P and P dash. Now as we know, according to the XOR rules, A XOR B is equal to C, then C XOR B is equal to A. It is defined in the XOR. So what happens is, when P dash is equal to P XOR C XOR C dash, if we know P, C and C dash, it is very easy to obtain P dash. So the second plain text is easily retrieved from the first plain text, ciphertext, and the second ciphertext. And also in most cases, same key is shared by this station and AP. So this is also a case where a plain text attack can occur. Another attack is a message modification method, that is a type of integrity reducing, where what happens is the message is sent by a legitimate user. If the message sent by a legitimate user is M1F M2, it is just a string format. Okay, now attacker tried to replace F with F dash, that is he want to change the message as M1F dash M2 instead of M1F M2. So what he will do is, he needs to know only F and F dash. He already know M1 and M2. So usually the ciphertext is calculated as the message M1F M2, then the CRC MIC is included, that is CRC of M1F M2. The whole thing is concatenated and it is XORed with the key stream value KS. So this is the format of ciphertext. Now Attacker can intercept this ciphertext and do the following step. These are the steps done by the attacker. So initially what he will do is he will construct a string that is 0M1, which is a string of zeros of length m1, string of zeros of length m1, and it is attached with a f XOR f dash, which is again attached with 0 m2, which is a zero string of zeros of length m2. Now m1 m2 are length of the strings, and then calculate, this is the string format, and then it calculate the CRC of this string, that is CRC of 0 m1 concatenated with f XOR f dash concatenated with 0 m2. Now he produces the fake message as both this message and CRC is concatenated combined. Then this fake message is XORed with the original ciphertext message. So when it is combined and it's divided and XORed, we will get an output like M1 XOR M1 F dash M2 XORed with CRC M1 F dash M2, which is XORed with KS. From this, you can easily decrypt the message as M F dash M2, M1 F dash M2 concatenated with CRC of M1 F dash M2. So it was his motive to obtain M1 F dash M2, which he got it very easily just by combining the ciphertext with a fake message that he has created. So this is the method of modification of a message. Now we are going to discuss about WPA, that is already we have discussed about the WEP methods, but I've told you that even though authentication, confidentiality, integrity, various methods were implemented on WEP, it was not successful, and most of the methods have failed. So it started to build up a new method, a new data protection method, which uses WPA, that is wireless protected access. So WPA, the first method is TKIP, which is temporal key integrity protocol, and we are also discussing about a second method that is called WPA section 2, which is a CCMP method. So first we are going to discuss WPA, wireless protected access. It is the refined version of WEP when WEP became a failure. Okay, we can call it as TKIP also, which is temporal key integrity protocol. And what are the differences when it is compared with WEP? Actually, it was built up to overcome the drawbacks of WEP. Here it uses a RC4 encryption scheme as it was used in WEP itself, but the difference is it uses a 128-bit key. It uses a 128-bit key. And another difference is each frame is randomly and different encryption. For each frame it uses a random and different encryption key. So this randomness helps to avoid the non-plain text attacks. Another difference is it uses a 48-bit sequence counter. This one counts for each message so that the receiver will accept a message only if the sequence number is greater than the previous one. For each message it increments one value. So this is a very good method to avoid replay attacks. Now here in TKIP it uses a two-phase key mixing concept where it uses a pseudo-random. So here it uses a two pseudo-random functions, that is PR(1) and PR(2). And what is the input to PR(1)? Actually we will discuss it with a figure. Here in the figure you can see there are two pseudo-random functions, phase 1 and phase 2. And in the first pseudo-random function it uses a temporal key TK of 128-bit, then the sender's MAC address of 48-bit, and 4 MS bytes of sequence counter, that is 4 most significant bytes of sequence counter is used here, which is of 32-bit. Now in the pseudo-random function 2 it uses two least significant bytes of sequence counter, which is a 16-bit value. Then it obtains a RC4 key. Okay, so this is the concept of two-phase key mixing. In it is input to pseudo random function 1 is a 128 temporal key, send as MAC address and 4 MS bytes. Input to 2 is 2 LS bytes of the sequence counter. And here, as we are using a 2 LS bytes of the 16-bit sequence counter, it changes in every 2 raised to 16 frames. So here, for the PR of 1, it is computed very rarely and the computation's time is saved in this concept. Also, we are using a MIC message integrity check concept here, which includes a 64-bit MIC value, and it is a function of data in frame and some fields in MAC header. And one main advantage of this MIC value when it compares with the MIC used in WEP is that the WEP, it was linear. That is, A XOR B, if A XOR B is equal to C, then A XOR C is equal to B, that concept. But here it is non-linear. That is, MIC of M1 XOR M2 is not equal to MIC of M1 XOR MIC of M2. So this is the main advantage of this WPA concept in TKIP. So this figure I have already discussed about it. You can check it. Then we have the second method, that is data protection with CZMP. So what is CZMP? It is also known as, I told you, WPA section 2, or you can say CCMP is counter mode with CBC MAC protocol. Counter mode with CBC MAC protocol, where CBC is cipher block chaining and MAC is message authentication code. And it uses a AES algorithm. In the last two concepts, in WEP and WPA first section, we have used RC4 method, but in WPA2, that is CCMP, we are using AES algorithm method. You have already studied AES method in cryptography, and it uses it for encryption, authentication and integrity. Here, the temporal key, that is TK, a 128-bit key value, which is used for both encryption and back computation. Another difference is it uses a sequence counter, that is a 48-bit sequence counter itself, but it named differently as a packet number, which is represented as PN, and which will increment on each frame. That is, as in the before case, when one receiver receives a message, it will check for the sequence number, and if it is incremented by 1 than the previous message, then only this will be accepted. Otherwise, it is considered as a fake message and it will be rejected. So that is the concept of sequence counter. So this is the whole figure of CCMP. We can divide it into two parts, first part and second part. I will discuss one by one. The first part, it is the upper part which deal with the MIC calculation, that is message integrity check calculation, which initially includes an initialization vector, which is a 48-bit packet number value, can consider as a nonce. Then you have two other adder, add1 and add2, which are the additional authentication data. It contains some immutable fields of MAC header like sequence control, frame type, etc. And the plain text PI is the ith block of the plain text. You can have P1, P2, etc. Pn. There are n blocks of plain text, and PI is considered as the ith block of plain text. Now the second half of the figure, which is the MIC, is integrated with data and encrypted by the AES algorithm. Here we use a count function. It is a function of packet number, and in order to encrypt a ith block which calculate AI, as AI is equal to ETK of Pn plus I into J, encryption of packet number, that is IV, plus I into J, where I indicate the ith block, and J is a constant that is known to both sender and receiver, and the whole thing is encrypted with the temporal key TK. So this is the concept of ciphertext AI from the from this Pn and I into J. Okay. Now to compute ith block of ciphertext, we get AI XOR PI. So we have calculated the AI, and when it is XORed with the plain text PI, you will get the ciphertext CI. Now we have CCMP header and MIC. And at the receiver, what happens is it reverses the entire process and it performs decryption and MIC verification. So this is the concept of CCMP, which is also called WPA2. Thank you.